It's a great day here in our class, and welcome back to you. Again, my name is Sir Christian, your teacher for Mathematics 8. And for the continuation of our quarter 4, which is the statistics and probability, we will be having the counting the outcomes of an experiment. And for the lesson 4, it is fundamental counting principle. On our previous meetings, we learned that first three ways on how are we going to count the outcomes of an experiment in a probability. Now we will be proceeding to the last one, which is the fundamental counting principle. So to start this one, let's have a brain review. Let's recap first. I have here Johnny. It is one of my previous student. Hello there. My name is Johnny. My friend Jenny invites me to go to her 18th birthday party this night, but I am hesitant on what should I wear. I have two pairs of shoes. It is leather shoes and rubber shoes, two types of pants, black pants and jeans, and three long sleeves, which are red, blue, and polka dots. How many possible combinations of outfit do I have? And what is the best outfit for me? So here is your task. So first, the class will be divided into three groups. First group is for table. Second group is for tree diagram. And third group is for systematic diagram. So we will be using the group that we had yesterday. So since we had three groups yesterday, the first group will be in charge on doing the table. Second group will be in charge in doing the tree diagram. And lastly, the third group will be in charge in doing the systematic listing of that diagram. Second, each group will be answering the question based on the technique assigned to them. So you will be asking the questions. And what are our questions? First is that how many possible combinations of outfit do Johnny have? Next, what is the best outfit for him? Okay? So remember those two questions that I will be asking after your group discussion or group work. Each group will choose one representative that will be given 1 minute to present their work. So I will be giving you 5 minutes for this since we already discussed this yesterday. After 5 minutes, let's go back to our room and discuss your work. Welcome back, guys. So let's have the group one. Let's check if your answer is correct. Okay. So for the table one that you have, we have the same. Next, are we going to stop on the table one? No. Why? Because we have the table two. So in here, kindly discuss your answer, Pedro. Very good, Pedro. So your answers are correct. So in here, how many possible outcomes based on the table you made? So we have 12, correct? So what are those? Kindly discuss them to us. Very nice answer, Pedro. So group 1 got the correct answer. Kindly give them a round of applause. Very good, group 1. Now, let's proceed to group number 2. And they are tasked to do the tree diagram. Let us check if the group two's answers is correct. Very good, group 2. So we do have the same answer. Kindly discuss it, Petra, how you came up with that answer. Nice. So how many possible outcomes do Johnny has? So we have 12 possible outcomes. Nice. So next, let's proceed to group number 3. How about group number 3? So you will be having the systematic listing. May I see your answer? Very nice. So we have how many? Kindly discuss it. Dexter? Yes, Dexter, your answer is correct. So we have 12 outcomes. And if you're going to choose what possible combination will you going to wear if you are Johnny? Okay, so you will be using or wearing jeans, rubber shoes, and polka dots. So you're a fan of polka dots. That is nice color as well, and nice design. Okay, going back to our discussion, how many possible outcomes? So we have 12 possible outcomes. So we do have different techniques. We came up with the same answer. So those techniques are just three different ways on how we get the possible outcomes. But class, we do have the shortcut on getting of it. Well, how do you think so? What are we going to do? You know what? After this discussion, you're going to be a probability expert. Why? Because you don't need to use the tree diagram, the systematic listing, and the table in getting the total number of possible outcomes. So, what is that? We already have the hint on the title of our topic. What is that again, Patricia? Very good. So, that is fundamental counting principle. So for this lesson, our objectives are the following. First, differentiate the two fundamental principles, the rule of sum and rule of product, followed by use the rule of sum and rule of product to solve probability problem. And last, write a student's experience that shows fundamental counting principles. So those are our objectives. So let's start. Let's study now. So again, we have the same scenario. Now, think of this. What are the numbers in the variables and what should you do to get 12? Isn't it 12 is the total possible outcomes? So what are the numbers? Nice. So we have 2, 2, and 3. 2 for shoes, 2 for pants, and 3 for sleeves. And what do you think so? Oh, what are we going to do to those numbers in order for us to get the 12? Correct? Again, what is that? Can you repeat Jessica's answer? Um, how about you? I think you are excited to answer. Billy. Okay, Billy, your answer is correct. We need to multiply them. So 2 multiplied by 2 is 4. 4 multiplied by 3 is 12. So in that case, we do have the shortcut. We just need to multiply the variables. Then we will be getting 12. Do you have any shortcut? That is the shortcut. So we have the fundamental counting principle. Let's go ahead and try to think of this scenario. What is fundamental counting principle? The fundamental counting principle is a rule used to count the total number of possible outcomes in a situation. So this is a rule. Therefore, we must follow a certain rule in order for us to get the final outcomes in a situation. So we have here Margaret. After Johnny, we have Margaret. Now, Margaret is thirsty. So she goes to the fridge to get a drink. Inside the fridge, there are two glasses of water, three bottles of soft drinks, and four cans of fruit juice. This is a simple one. If she can only choose one, how many options does Margaret has? How many options does she has? So we have 2 plus 3 plus 4. And what is the final answer? You just need to add them. 2 plus 3 plus 4. The correct answer is 9. So Margaret has 9 options or has 9 choices for her to have her drink. So on this case, what operations do we use? How about you, Jasmine? Obviously, correct. That is addition. Isn't it? If you remember, on our objective, we do have two rules. So we have the rule of sum and the rule of product. A while back on Johnny's situation, we used the rule of product. But for Margaret, we have or we use the rule of thumb. Why? Because if you're going to notice this one, she just need to choose one among the options. She cannot drink all of them. Why? Because based on the question, it can be one glass of water, one bottle of soda or soft drinks, or one can of fruit juice. But how many choices? Nine. So that is the rule of thumb. Again, for Johnny, we have the rule of product. For Margaret, we have the rule of sum. What is FCP again? FCP is the fundamental counting principle, and it will make us a probability expert if we master this concept. So mastering this concept will help us to understand more what is probability and what is statistics as well, because they do go hand in hand, probability and statistics. Next, an important part of probability is counting the number of outcomes of the events, or what we call the sample space. Again, sample space is the list of all the possible outcomes. For sample spaces or events with a small number of outcomes, this can be done by listing down or directly counting all the elements in the sample space. But for larger sample spaces or events, we will need some counting techniques, and those are the fundamental counting principles. In this lesson, we look at two principles, and what are those? The rule of sum and the rule of product. As these properties central in most counting problems, they are called sometimes as the fundamental counting principles. So let's have more example of this. If a particular action can be done in m ways and another in n ways, and the two actions cannot be done at the same time, then there is m plus n ways in doing exactly one of these situations. So that is the rule of sum. Remember this, guys. When are we applying the rule of sum? We are applying the rule of sum if we do have options but cannot be done at the same time, and we just need to choose one of those choices. So example, number one, Aldrin wants to travel from Pampanga to Boracay. Maybe he wants to unwind and have some swimming over those beaches in Boracay. He finds out that there are two possible flights and five possible ferries for today. Assume that he wants to travel today and that he has no restrictions on which mode of transport and schedule to take. How many possible choices does he has? Okay? How many possible choices? Any volunteer? Okay, I think Johnson is raising his hands. Yes, Johnson. How many possible? Oh, how do you came up with that answer? What is your answer again? So seven. Why do you think so? It is seven. Let's check if your answer is correct. So we do have two possible flights, five possible ferries, or five possible ferries. Again, according to the rule of sum, what operation are we going to use? It's addition, so we just need to add, and we have seven ways. Any question, class? If you have some question, do not hesitate to raise your hand immediately so that I can address that question to you, because I don't want to leave anyone behind. Example number two, Brian is preparing for the report and he needs to choose a template for his. In his computer, there are three folders of templates. So we have three folders of templates having 12, 13, and 25 different designs. If you are Brian, how many ways can you pick the design for your template, assuming he can only choose one template? Let's check. So for the first folder, we have 12 designs. Second folder, we have 13 designs. Third folders, we have 25 designs. So according to the rule of thumb, what operation are we going to use? So we will be adding those designs. So 12 plus 13 plus 25. Again, plus points to the first one who will get the correct answer. Yes, Aldrin. Very good, Aldrin. So we have 50 ways. So plus 2 to your ways. Remember that, Aldrin? Next, how about this one? The CDS milk tea shop allows the customer to make their own milk tea. I hope all can do that. Wherein they can select the tea base and one order of sinkers. So tea base, sinkers. For the tea base, they have black tea, green tea, Earl Grey tea, and red tea. For the sinkers, we have the pearls, nata de cocoa, pudding, rainbow jelly, and cream puff. Now, this is the question. How many possible combinations of milk tea can you make based on the given milk tea base and sinkers? Okay? I will be giving you 30 seconds to think of it. Then let's check if your answer is correct. Okay, so 30 seconds is up. So let's discuss this one. Are we going to apply the rule of thumb here? If you're going to notice, we cannot add black or the tea base and the sinker. Why? Because on this case, we need to choose tea base as well as sinker. Isn't it? For the rule of thumb, you just need to choose one. But for this, it is a combination of a tea base and a sinker. So let's try to analyze this. In the black tea, we can prepare that to five sinkers, and those are the pearls, nata de coco, pudding, rainbow jelly, and cream puff. So for here, we can have five outcomes. So we have the black tea with pearl, black tea with nata de coco, black tea with pudding, black tea with rainbow jelly, and black tea with cream puff. So that is just for black tea. We have five for black tea. And how many for green tea? Another five for green tea. How about the Earl Grey tea? So we have another five. And lastly, for the red tea, we do have five another choices. So in all, how many choices do we have? So for tea base times five sinkers, so we have 20 ways. So based on the operation that we use, that is for the rule of product. So defining rule of product. So generalizing this to any two actions, we obtain the second fundamental counting principle, which is the rule of product. The rule of product can be subdivided into two, namely the multiplication rule or the multiplication principle and the general case. For the rule of product multiplication principle, remember we have two rule of product. First one, we have the multiplication principle. If a particular action can be done in m ways and another in n ways, then there are m times n ways of doing both action, one after the another. So if you remember the milk tea scenario, isn't it? We are obliged to choose how many action? Two action. First, choosing the tea base. Second, choosing the sinkers. So those can be done both. It means we cannot order just tea base. We cannot order just sinker. So in order for us to have a one order, we need to order tea base together with the sinker. Also, that falls under the multiplication principle of the rule of product. So 40 times 5 sinkers is equal to 20 ways. How about the rule of product with general case? So given K actions, K stands for the number of actions that we need to be done in a certain scenario. If the first actions can be done in n sub 1 ways, the second action in n sub 2 ways, and so on, then there are n sub 1 times n sub 2 times and so on and so forth up to the n sub k ways of doing all of the k actions. Note that the letter k stands for the number of actions needed. For us to understand this one, let's have the example number 4. Mario wants his hair to get cut and fixed. So maybe Mario is a good looking person because he wanted to cut and fix his hair. On their place, they have three barber shops. For each barber shop, there are five barbers. Each barber has three kinds of shampoo and two kinds of gel and hair wax. Or how many ways does Mario has to fix his hair together with the shampoo and the gel or hair wax? Now, how many actions are we going to consider? Isn't it the first one? Mario need to choose among the three barber shops. So we have the first action, choosing the barber shop. After that, after he had chose a barber shop, second is among those five barbers on that barber shop, who is he going to choose? So again, choosing barber shop, choosing barber, next, choosing shampoo and choosing hair, wax, or gel. So we have four actions that we needed to be done. And to solve this one, let's have this. So for the solution, we do have three barber shop, five barbers, three kinds of shampoo, two kinds of gel and hair wax. Multiplying them all, we will be having 90 ways. Okay, just simple as that. So 3 times 5 is 15. 15 times 3 is 45. And 45 times 2 is 90. I hope we are getting it clear. Game time! And what is our game? So we have the pass the ball. So here is the instruction or the mechanics for this game. And be prepared. All can answer, all can participate, and we do not know who are we going to choose or who among us will be answering this question. So to develop our mastery of the lesson, let's have some examples and play the pass the ball. So here is the instruction. In this play, I will pose a scenario and then a series of questions will be asked to dig deeper the understanding of the students in the lesson. For the first question, the teacher will choose a student to answer it. So for the first question, I will be choosing one of you to answer. Then for the second question, the first student that was chosen will choose or pass the ball to another student to answer it. So the person that I chose will choose another person to answer to the for the second question. This action will be done repeatedly until all questions will be answered. So let's have this one. Johnny wants to watch movie. Upon going to cinema, there are three comedy movies. Remember those choices. Two horror movies, four romance, and one drama. I kindly help John to choose a movie. So here is the first question. Question one. What principle can be applied? Is it rule of sum or rule of product? If your answer is rule of product, which of the two? Is it multiplication principle or general case? So let's try. Yes. How about you, Joms? What is your answer? The answer is rule of sum. Correct. So pass the ball now to your classmates. Whom are you going to choose? You can choose your crush, your best friend, or anyone in the class. Yes. So you are the lucky one, Christine. So for question number two, kindly read the question number two, Christine, and answer it for us. Oh, how many options Jan has? Oh, nice explanation. So since it is a rule of sum, you need to add the variable. So 3 plus 2 plus 4 plus 1, correct. The answer is 10. So we have 10 ways. Pass the ball now. Nice. If you were John, what movie will you watch and why? Oh, this is an easy question. So what are you going to choose? Ah, okay. You choose Christina since she loves watching K-drama. How about you, Christina? If you're going to choose, which what kind of movie? Oh, drama. Because you love those touching kind of movies. That's nice. That's next. Then next, let's proceed. Awesome. Ayan. Students, answer may vary. It's up to you. What kind of answer or what kind of movie are you going to watch? Let's proceed to the next scenario. So Jessica, a beautiful lady, wants to look elegant while attending prayer meeting in their church. Inside her closet, there are five blouses, plain white, plain yellow, plain blue, floral red, and floral white, and four skirts, two black, one white, and one yellow. Kindly help her choose a dress. So the first question is this. Okay, Christina, before you choose the person, kindly read it first for them. Nice. So whom are you going to choose? Katie. Okay, Katie, how about you? What is your answer? So let's check. So the correct answer is rule of product. Nice try, but uh, why do you think so? Your answer is rule of sum, but the correct answer is rule of product. Now that you know that it is rule of product, I explained it to us so that I can give that as a point for you. Correct? Ayan. So we will be needing how many actions? Two actions. And what are those? First, you need to choose the blouse and choose the skirt. And that is for multiplication principle. Next question. How many options Jessica has? Oh, how are you going to choose? Okay, how about you? Jerjon. Jerjon, how many options Jessica has? Let's see. Correct. So we have 20 ways. 5 times 4 is 20 ways. Awesome. Pass the ball now to your classmate. But before that, let's have the question. If you were Jessica, what pair of blouse and skirt will you wear? And why? Oh, this is just a simple one. You just need to wear. Of course, do not call for a boy. You must call for a girl. Maybe if you call for a boy, he will be wearing a skirt and a blouse. So let's check. Ah, okay. So you want Nicole to answer. Yes, Nicole? What is your answer? Ah, so you will be uh choosing plain white and white skirt. Why? Oh, that is nice because she will be attending prayer meeting. I might as well will suggest Jessica that she will wear the white one. Let's proceed to the next scenario. Maria wants to buy ice cream. Oh, this is ice cream, and I really love ice cream. In the shop, there are 8 different flavors, 4 types of cones, 5 different toppings, 3 sizes, small, medium, and large. Can you tell me how many possible combinations of ice cream do the shop has to offer? But the first one question is, what principle can be applied to the rule of sum? Is it rule of sum or rule of product? Nicole, whom are you going to choose? Yes, Ryan. What is the correct answer, Ryan? Let's see. So you got it right. That is rule of product general case. And how many options Maria has? Whom are you going to choose? Ryan. So you will choose your best friend, Raul. How about you, Raul? What is the correct answer? Let's check. So we have 8 times 4 times 5 times 3. So 480. You got it right. Good job. For the next question, why does this example falls in general case and not on multiplication principle? Why do you think so? Why is it is on the general case and not on multiplication principle or multiplication rule? Yes. Whom are you going to choose, Ryan or Raul, brother? Ah, okay. So you're another best friend, Luis. Yes, Luis. Okay, so you think so this will fall on the general case because we do have many actions needed in order for us to get the order of an ice cream. So correct. Application time. You ask, I'll answer. So this will be another group work. And read the instruction. Jeremiah. So first part, the class will be divided into three groups. Then each of the group will create a real life scenario that shows the assigned fundamental counting principle with corresponding three questions like what we did on the previous activity. Remember the questions that we asked a while back? So first one, must need to ask again, you must need to ask which rule. Is it rule of sum, rule of product, and which of the rule of product? Is it multiplication principle or general case? You can choose on the following settings. So you can consider this one. A is school, B house, C market. So it can be that your scenario falls on this setting. On the second part of the activity, the scenario made by each group will be given to the another group for them to answer the question. So the scenario that you made will be passed to another group. For example, group 2 will answer the scenario created by group 1 and so on and so forth. So there will be an exchange of questions so that I can analyze or I can check if you really understand it. Don't you worry, I will not be assigning those person that will answer. Rather, we will do it on the spot so that I can know if you really participated on your group. So good job, everyone. We made it. We do have your answers, and I think you really understand our lessons. You answer all of the questions of the other group correctly, and that is a nice work and good job to all. Now, math recap. Let's have a recap before our quiz. So to sum up the discussion for today, the total outcomes of an experiment can be represented through table, tree diagram, systematic listing, and the other one is the fundamental counting principle. So for the fundamental counting principle, ayan. So again, it can be tree diagram, table, systematic listing, fundamental counting principle. It is a counting technique that can be used in determining the number of total possible outcomes in an experiment. So first we have the rule of sum, and this is the um, this is the rule of sum. If a particular action can be done in m ways and another in n ways, and the two actions cannot be done at the same time, then there is m plus n ways in doing exactly one of these actions, followed by the rule of product. If a particular action can be done in m ways and another in n ways, then there are m times n ways of doing both actions. And last, rule of product general case. Given k action, if the first actions can be done in n sub 1 ways, the second action in n sub 2 ways, and so on, then there are n sub 1 times n sub 2 times n sub k ways of doing all of the k actions. Note that the letter k stands for what? Very good. That is for the number of actions needed. So for the quiz, I will be pausing this one, then I will be giving you 10 minutes since it is just for a short quiz. So for the instruction, read each scenario carefully, determine which fundamental counting principle can be used, then solve for the total possible outcomes. You just need to choose the letter of the correct answer. Again, I am trusting in you. Please do not cheat and please read carefully and try to analyze each of the question. So we have the number 1 and 2. So for scenario 2, we have the 3 and 4. Okay, so after you had answered it, let's proceed to the second one. So scenario 3, we have that one. Kindly answer it. So 2 minutes has passed. Let's proceed. For number 7 to number 10, write your own experience. A while back, we made it as a group. So for today, for our quiz, you must do or write your own experience in this time of pandemic that shows fundamental counting principle. Consider the guidelines below. So here are the guidelines. Choose among this concept. It can be online class, module, it can be about your family, social media, or it can be about yourself. Identify the factors of your choices in that experience. Determine the total possible outcomes and tell the decision that you made. Example in this, it is just a simple one. It can be a one single sentence. So during the online class, I experienced to have activities in different subjects. So there is a time wherein I have four in Filipino, six in mathematics, five in English for a week. Despite having 15 total activities, I choose to answer the first activity in mathematics because that is my favorite subject. So scrutinizing it, let's check if this example falls or follows the guidelines that we have. First, choose among the concept. What concept? Online class. Check. Identify the factors. What are the factors? So we have four activities in Filipino, six activities in mathematics, five activities in English in a week. So those are the factors. Next, determine the total possible outcome. So on this scenario, he says, despite having 15 total, so 15 total activities, that is for the possible and outcomes. And lastly, tell the decision that you made. So the decisions are I choose to answer the first activity in mathematics. As simple as that. It can be one single sentence, two to three sentence, but three I think will be the maximum for this activity. Remember that is for 4 points, 7 to number 10. Okay, since you are done answering it, let's check. So for number one, the answer is rule of thumb. Why rule of thumb? Because we need to add the supermarkets or the options or the stores that mother has. Next, we have 13 ways. Why 13 ways? 10 plus 3. As simple as that. Scenario number two, number three answer is rule of thumb as well. Why rule of thumb? We just need to add all of the options because we just need also to choose one of those options. And how many possible ways? So adding them, we have six in Zambales, three in Bulacan, and four in Bataan. We have 13 ways. Next, for number five, we have the rule of product general case. Why general case? Because we have two to three more or two or more actions that needed. And first, we have to choose the flavor of the patty, choose the types of the buns, choose the types of cheese, and we can also choose if we can add egg or not. So the possible answer is 48 ways. Okay? For number 7 to 10, I will be the one who will check that and I'll update you on our next meeting if you got it right. Next, brain twister. So I will be leaving this question and let's see if you will get this one correct on our next meeting. So this will serve as your assignment as well. Think about it. Be a detective. I know all of us, if not most of us, want to solve like a detective. Imagine this, you were locked. Oh, in an isolated room, and the only way to get out of the room is to solve the four-digit password of the locked door. To get the first two digits, you need to solve for the first question. And to get the last two digits, you need to solve for the second question. If I have 12 apples, 13 oranges, and 30 grapes, and I just need to eat one of them, you just need to eat one of them. How many choices do I have? In a mall, there are six gates. That is for entrance and exit. So in a mall, there are six gates that can be for entrance and that can also be for exit. How many possible ways can I enter and exit in that mall if I will not exit on the gate that I enter? Try to think about it. What is the password of the door or of the lock? I hope you learned our discussion for today. But before that, let's have the Math Wizards lesson or a points to ponder. Again, what is our motto? Teamwork makes the dream work. Remember that, guys. Even if it is not in mathematics, even in other subject or other field of life, you still have to apply this. Thank you for always listening to my discussion. Hope you enjoy learning. Good day and bye bye.